So, good afternoon, everybody. Myself, Acharya Vishvendra, and today we shall be discussing bulk modulus of a gas. Let's begin with things in proper perspectives. So, here is the worksheet on the bulk modulus of gas. So, first question is for gases, bulk modulus is. So, for gases, bulk modulus is minus V into dP by dV. Next is for isothermal process, bulk modulus is. So, it is equal to the pressure P. Next is if we draw graph between isothermal bulk modulus and pressure. So obviously bulk modulus is equal to P. That means graph is a straight line with slope equals to B by P, which comes out to be 1. So the slope angle here comes out to be 45 degree. Next is we have three different gases, but isothermal bulk modulus is equal to pressure. So all the angles will be equal here, will be equal to 45 degree. However, for adiabatic process, bulk modulus is equal to gamma into P. So if we draw graph between bulk modulus and pressure, its slope will be gamma, or tan theta will be equal to gamma. Now there is another question that ascending order of gamma is that gamma for monatomic is greater than gamma for diatomic is greater than gamma for non-linear polyatomic. So if we are given three graphs corresponding to three gases, so the if theta 3 is greater than theta 2 and it is greater than theta 1, it implies tan theta 3 is greater than tan theta 2 is greater than tan theta 1, which implies gamma 3 will be greater than gamma 2 and it will be greater than gamma 1. Next question is bulk modulus for isochoric process is. So for isochoric process, bulk modulus is infinity. Next is bulk modulus for isobaric processes. For isobaric process it is 0. Next question is a gas behaves as a perfectly rigid body during. So perfectly rigid body means bulk modulus tends to infinity, which refers to the isochoric process. Next is a gas behaves as a perfectly plastic body. So perfectly plastic body means B is equals to 0, which corresponds to the isobaric process. Next is we are being given two graphs and we are being asked that which graph corresponds to isothermal process. So obviously slope of isothermal is less. So the first one corresponds to the isothermal process. In the next question, which graph corresponds to adiabatic? So theta 2 is greater than theta 1, so it corresponds to the adiabatic process. 15 tan theta 1, we know that in isothermal process slope is 1, so tan theta is equal to 1 over here. Next is we know that in adiabatic process tan theta is equal to gamma, so it's gonna be gamma. Now there is a question on adiabatic bulk modulus and three different cases are given. Three gases are given here: helium, oxygen and ammonia. So graph 1 corresponds to, so you can see that 1 has the least slope, that means it has least gamma, and least gamma corresponds to non-linear polyatomic, which is ammonia over here. Next is graph 3 corresponds to, so graph 3 has highest slope, that means highest gamma, so it's correspond to monatomic gas, which is helium over here. So these are the basic worksheet tools on bulk modulus of gas, and these are aspired to make you quickly revise all the relevant facts, concepts and tricks related to the subtopics so that you can give a final touch to your exam preparation. I hope these will prove to be a boon to your preparation and optimize your time and energy so that you can score better and perform better in your exams. Thank you and have a nice day.